Hello and welcome. My name is Shahid Latif, a PhD candidate at University of Duisburg-Essen, Germany. Today, I am pleased to present our work on a mixed initiative interface for authoring interactive documents. It is the result of a collaboration with Zheng Zhou, Yoon Kim, Fabian Beck, and Nam Woo Kim. Let's begin with an excerpt of an interactive article written by Mac Perry and Brian Card. It visualizes and describes Boston's subway system. As a reader reads through the text, relevant parts of the visualizations are highlighted. For instance, first the train stations that are busy in the morning, and then the ones that are busy all the time. Such articles aim at providing an interactive reading experience through visual annotations and cues, similar to the signaling principle in multimedia learning. Existing research has already provided evidence that such interactive linking between text and visualization can be beneficial. It can improve information recall and comprehension, especially for people with low visualization literacy. It may also reduce the cognitive burden on the reader. However, existing authoring tools do not support the interactive referencing of text and charts. Therefore, practitioners resort to manually coded solutions in programming frameworks, for example D3, IDLE, or similar. Such solutions require huge effort and advanced programming skills to produce interactive content. With this limitation in mind, we set out to develop an easy-to-use tool for authoring interactive references between text and charts. First, it was important to understand the design space of references that are present in existing data stories. We used the work of Kong and others as a basis for our analysis. Their dataset was small and limited to articles including bar charts alone. We extended their dataset by including 55 more articles with a wide variety of chart types. We also diversified the venue of these articles, ranging from news media outlets to research papers published in various scientific journals. We broke down the articles to individual sentence chart pairs for our analysis. Since majority of these articles did not include interactive references, we manually labeled parts of the text that referred to visual marks in the chart. Through the analysis, we found that textual references bear close resemblance to the data selection in a chart. For instance, in this example, the country names Spain, Italy, UK, and Ireland refer to the selection of individual dots in the scatter plot. Similarly, terms like EU could refer to the selection of a set of points in the scatter plot. We refer to these as point or multi-point selections. Textual phrases may also refer to a numerical range, just like an interval selection in a chart. Here, the green highlighted phrase is referring to the 4 countries falling in the income range between $30,000 and $39,000. We also observed that references can be grouped together in a hierarchical manner, just like a dependency parse tree of a sentence. The second sentence in this example contains 3 references, 1 multi-point reference and 2 interval references. They can be grouped in the order shown here from bottom to top. It was also found that whenever references are grouped, the corresponding sets of data points in the chart go through union or intersection operations. References also relate to visualization analysis tasks. For more details, please see our paper. Having understood various types of references through the design space analysis, we came up with 3 design considerations for our tool. First, the tool should be able to automatically detect point and interval references as well as group them if possible. Second, the tool should only assist by suggesting potential references to the user and do not create them. This is important because any automatic reference detection system would result in false positives that may annoy the user. And finally, users should not be limited to what is suggested. Instead, they should be offered an intuitive interface with minimal interactions to construct their own references. Now let's look at Kori, our authoring tool with a focus on creating interactive references between text and charts. The interface is simple. It consists of a chart gallery, and an editing panel. Charts can be added to the chart gallery by dragging and dropping their VIS' specifications in the form of JSON files onto it. Charts from the gallery can be added to the editor through drag and drop again. As the user is typing, presence of potential references is communicated to the user through gray underlining. Users can preview them by hovering over the underlined text. Users can select any portion of the text or type the @ symbol to trigger automatic suggestions. Let's look at how do we automatically detect these references. Our reference detection pipeline accepts text and VIS' specifications of a chart as inputs. In the second step, we extract features of a chart, namely data labels, axis labels, legend labels, etc. These are the elements of a chart that can be referenced. In the third step, we try to identify the portions of the text that match to some chart feature. For instance, Google matches to its symbol in the legend. Then, we use a rule-based approach to detect numerical intervals in the text. These rules we utilize here come from our design space analysis. The final step is the grouping of the identified intervals with the corresponding point reference. To match the interval to the correct axis, we use distances in the dependency tree space of the sentence. The axis interval pair with the least distance is grouped together. To manually construct a reference, users can select a portion of the text and activate the manual construction mode as shown. A reference can be constructed using one of the two available modes. The first one involves adding filters and specifying their values. Users can add multiple filters. Second is the direct manipulation mode. In this mode, users can use point selections or brush selections to select the visual marks of interest they would like to create a reference to. The created references are underlined with blue color to differentiate them from suggestions. This way, users can continue to add more charts, text, and construct more references. The evaluation of Kori is twofold. We did an algorithmic evaluation of the automatic detection pipeline and conducted a small-scale user study to see the usability and usefulness of the tool. The evaluation dataset included 92 chart text pairs with 15 different charts. This was randomly split into a validation and test dataset. The dataset included 137 true references. We chose the parameters that maximize the F1 score. Overall, our pipeline correctly identified 57 references. Individually, the interval extraction and grouping of references was more challenging than the detection of point references. For the user study, we recruited 11 participants with diverse backgrounds: 6 undergrad and grad students, 4 visualization experts, and 1 user interface designer. The participants had to do 2 replication tasks and 1 creative task about authoring an interactive story, followed by a reflection survey. Each session lasted around an hour. Here you see 2 selected stories that the participants created. The blue hat symbol marks the references that were suggested by Kori. It shows that the participants got meaningful suggestions while writing. Other references were created by users using the manual construction interface. Small histograms show the distribution of participants' rating for various aspects of Kori. The data was collected on a 5-point Likert scale, with 5 being the highest rating they could give. All participants agreed that the tool is intuitive and easy to use. In reference to the usefulness, one participant commented that she wasn't sure about a statement she was writing, but through interactive referencing, she could verify it. The participants had mixed feeling about automatic suggestions, as one participant commented that they are good, but not smart enough. All participants praised the manual reference construction interface. The tool has some limitations. For instance, the absence of a chart creation interface might limit the analysis options while writing. Kori has no support for establishing a reference to multiple charts. Also, the references can only be created from text to charts and not the other way around. Lastly, the accuracy of automatic detection pipeline is low. We believe that these limitations can lead to exciting future directions to our work. That brings me to the end of my presentation. Thank you for listening.